We're going to start the story where we always do, with the 3 prongs of Gingles. The first prong being that the minority community has to be sufficiently large and geographically compact to constitute a majority of a single member district. The second is that the minority group must be politically cohesive. And the third, that the majority group consistently votes as a bloc to defeat the minority preferred candidate. So how do we know if minorities are politically cohesive? And how do we know if whites are bloc voting? According to the Supreme Court in Thornburg v. Gingles, the answer is that we have to do a racial bloc voting analysis. The racial bloc voting is the linchpin of a voting rights Section 2 case, and it involves a statistical analysis. Jose, could you move to the next slide, please? Okay. So what does this mean? What does it mean when we talk about voting being racially polarized? Essentially, we mean that the candidates preferred by the minority group is different than the candidates preferred by white voters. And if the candidate preferred by white voters usually wins, the degree of racial bloc voting rises to be legally significant. Now, if voting is polarized, consistently polarized, and the minority preferred candidates consistently lose because whites are not voting for these candidates, and you can draw a single member district in which minorities constitute a majority of the population, then you need to draw districts, that at least a district, possibly more than one district, that would provide minority voters with an opportunity to elect their candidates. Okay. I talked very briefly, I talked more than very briefly last time about the data that you need to do a racial bloc voting analysis, but I've listed these on a slide, Jose. The next slide, please. We need to look at 2 pieces of information. First of all, this is going to be an aggregate level analysis. We don't know how individuals are voting, and so we're going to try and get at it through the back door using election precincts. And we're going to look for patterns across election precincts. And we're going to do this with 2 pieces of information about the election precincts. The first thing that we're interested in is the voting patterns of these precincts. And this just requires election results. And the election results, at least in terms of statewide elections, are usually available at the precinct level on the Secretary of State or Board of Education's website. You can just download them. The most relevant contests would be the precinct contests that include minority candidates and that are for the office at issue. So if you're looking at congressional elections, you'd be most interested in, if you're looking at congressional districts, you'd be most interested in, for example, congressional elections. The second piece of information that you need is the demographic composition of the precinct. And I talked at length the last time about some of the ways that we measure the demographic composition of the precinct depending on the data that we have available for us. We will always have voting age population by race, thanks to the census. We can always calculate citizen voting age population if this is of interest to us, depending on whether we have a lot of non-citizens in the minority group that we're interested in. Harder to get is registration or turnout by race. And then we have some other ways that we can try and get at what the demographic composition of the electorate is if we have a voter file with names on them, and we can use the surnames to identify the race of the voter. Okay, next slide. So what do we do with this information? The simplest thing that we could do is we could identify those election precincts which are overwhelmingly one race. So if we took a look at all of the precincts in which we know the voters are all likely to be, say, for example, Black voters, and then determine how those precincts are voting, that would be our estimate of how Black voters are voting. And the same for whites. I did grouping together all of the precincts that are overwhelmingly white and determining how those precincts are voting and using that as an estimate of how whites or Black voters vote. Now, there are a couple drawbacks to that. And the first is that some jurisdictions have no homogeneous precincts, especially if you're talking about minority groups. If they do, there might only be a handful. And it may be the case that you don't want to, well, most likely it is the case that you don't want to estimate the behavior of, say, Hispanic voters in general on the basis of a small group of homogeneous Hispanic precincts. This is a small number of voters, and more particularly, they might not vote the same as Hispanic voters that live in, say, more diverse precincts, and the same is true of white voters. White voters that live in homogeneous white precincts may well vote differently than white voters that live in more integrated precincts. However, homogeneous precinct percentages are usually a good check on the estimation procedures that I am going to discuss in a minute. Because first of all, this is not an estimation procedure because these are actual numbers. We're talking about the actual voting percentages from these precincts. They're only a check because, again, this is not representative of all of the voters of that particular race in the group. Okay, next slide. So we're going to use, there are two methods. I use both of them, but you would at least use one of these two methods to derive estimates of how minority and white voters are voting. The two procedures are called ecological regression analysis and ecological inference analysis. They're called ecological because we're using aggregate level data. We're not looking at individuals, we're looking at precincts. And they're going to rely on different statistical approaches. I use both because if you get the same or nearly the same estimates using both procedures, you can be fairly certain that you have a good handle on how these groups are voting. Okay, let's look at ecological regression analysis first because that is the simplest to describe. What I've done here with this scatter plot is each point on this scatter plot is a precinct. And the precinct has been placed on this scatter plot on the basis of the two things that we know about the precinct. And that is, in Georgia, I should mention, we actually have turnout by race. So we know the proportion Black turnout of the precinct. And in the election we're looking at here is the 2021 elections runoff for US Senate with Raphael Warnock. And so the other piece of information we're using to place the precinct on the scatter plot is the proportion of votes for Warnock. So each precinct is placed here on the scatter plot, and you can probably see a very distinct pattern, and that is the higher the proportion Black turnout, the higher the votes for Warnock. And we're going to use this relationship to estimate the percentage of Black votes for Warnock. Okay, next slide. So we're going to produce what we call the best fitting line to these points. The computer will do it for us. It's going to find a line that the distances of each of these precincts from the line is the shortest, is the smallest. And we are going to then use the line to, at one end, we'll have the percentage of non-Blacks who voted for Warnock. And at the other end of the line at which Black turnout is 100%, we're going to use that as our estimate of the percentage of Black voters who supported Warnock for that particular, that was a county. Those were precincts within a specific county in Georgia. And that would be our estimate of the percentage of Black voters who voted for Warnock. Okay, next slide. Ecological regression and homogeneous precinct analysis were the two methods used by the, at least the plaintiff's experts in Thornburg v. Gingles. So these were the only two methods that were available in the 1980s when the case was decided. There are two disadvantages to ecological regression analysis, and one is evident by looking at the scatter plot, particularly when voting is quite polarized. You can see that the line where it hits the 100% point is actually over 100%. So one of the disadvantages of ecological regression analysis is it produces estimates that can fall outside of the logical bounds. You can get an estimate of, say, 103 or 104% of Black voters supporting Warnock, for example. And you could get something like -4% of white voters supporting Warnock. And this is particularly true if voting is very polarized, or if your precincts don't span the entire length of the horizontal axis. In other words, if you don't have precincts that fall, say, at 10, 20, 30, 40, 50, and upwards to 60, 70, 80% Black turnout, then you can get lines that go outside the bounds. The second problem with ecological regression is that you're assuming the pattern is linear, and that is that the percentage of votes for the candidate that you're interested in is constant across the precincts, that the same amount of votes for that candidate from Black or white voters is the same across all of the precincts. That's what's inherent in producing a line here, is there's an assumption that the support across all of the precincts for the two groups that you're interested in is constant. So in the 1990s, Professor Gary King at Harvard was looking at these potential downsides to ecological regression, and he developed another technique. And this technique is called ecological inference. Next slide, please. So, he was prompted in part by the out of bounds estimates, but also a little bit nervous about the idea that we have to assume a constant relationship in the voting patterns across precincts. So he designed a method that, number one, never produces estimates that are outside the logical bounds, and number two, does not require an assumption of constancy across the precincts in terms of voting behaviors. On top of that, you'll recall that we put our precincts on the scatter plot on the basis of two pieces of information: the proportion Black turnout and the proportion of votes for Warnock. Professor King said there was more information there that we can use to produce our estimates. So instead of each precinct being represented by a point, it's represented by a line. And let me explain where that line comes from. Next slide, please. We not only know the, say, proportion of Black turnout, but we know, given the votes for that particular candidate, we can estimate the maximum and the minimum number of, say, Black voters and white voters who supported that candidate. So in this particular example, we have 100 voters, 60 who are Black and 40 who are white. We know that candidate Z received 50 votes. And from that, we can say either that most votes that they could have received, candidate Z could have received, is 50, which left 10 Black voters voting for another candidate. And the least is, in fact, he could have gotten all of his votes from the candidates. He could have gotten all of his votes from Black voters. And so we can use this. And if you assume the maximum number of Black voters voted for Z, then the minimum number of white voters would have been 10. And for each point on that line in that graph, you have the maximum number of one group and the minimum number of the other group that would have had to have voted for that candidate. And the real value is somewhere on that line. So now, instead of a single point, we have a line, and the truth of the matter has to be somewhere on that line. Okay, next slide. So now our scatter plot looks a little bit different. This is called a tomographic plot. Each precinct on this is a line now instead of a point. Along the horizons, we have, along the axes, we have on the horizontal the proportion of Black voters, and on the vertical the proportion of white voters that would have had to, that could have possibly have voted for that candidate given the results of the precinct election results. And the single point is our best guess estimate of the proportion of Black and white voters that supported that candidate. And what you can see is a heavy grouping of the lines intersecting between about 0.8 and 1. So our estimate of the percentage of Blacks who supported Warnock is going to be somewhere between 0.8 and 1, or 80% and 100%. We're going to use something called the maximum likelihood estimation procedure to come up with a single point, in essence, where all of the points, the best guess of where the intersection of all of those points are, to come up with our estimation of Black and white voters supporting a candidate. Next slide. Okay. So the drawbacks of EI are, first of all, it's very difficult to explain to the court. And one of the reasons that I use all three methods is it's easier to walk through the process, beginning with homogeneous precincts, then talking about ecological regression, and ending the story with ecological inference. A second problem is maximum likelihood estimation process is a simulation technique, and each time you run it, you get a slightly different answer. There is a way around that, and that is the simulation begins with a random collection of numbers, and you can see those numbers so that you could, in fact, get the same estimation each time you run it. But it is a simulation procedure. And finally, ecological inference was developed by what we call 2x2 tables. So you have two racial groups and you have two candidates. So we have Warnock and Loeffler, we have whites and Blacks. What happens when you have more than one candidate, more than two candidates? We run the process iteratively. So we run it this candidate, then that candidate, then that candidate. What if we have more than one racial group, more than two racial groups, excuse me? That becomes more complicated, because what you're going to do is you're going to produce your estimates of, say, Hispanic voters versus non-Hispanic voters, and Black voters versus non-Black voters. And these 2x2 tables when you're dealing with more than 2 racial groups, produce estimates that can be less reliable. So what happened more recently is that some political scientists and statisticians got together and found a way to expand these 2x2 tables. And this is especially important in jurisdictions where you have, say, where you're interested in whites, blacks, and Hispanics. Then you'll use most likely the what we call the R by C, that's rows by columns, where it's not constrained by 2x2 to produce your estimates. This has actually been brought into the court, but I'm not sure that the judges and the lawyers dealing with this know that, and the courts have never commented on it. But people who are using ecological inference more recently tend, if there are more than 2 racial groups, to use this R by C methodology. Okay, next slide, please. So we've done this estimation procedure. Now, what do the results look like? So these are actual results, just like the scatter plot and the tomographic plot were actual results from a county in Georgia. And here are the results. So we can see our 2 candidates, the race of each of these candidates, the party, the actual votes that they received in that particular county, and then our ER and EI estimates. So we have, according to ER, 94.9% of Black voters supporting Warnock. According to EI, it's 94.4%. And when you look at white voters, it's 23.5% if you're looking at ER, and if you're looking at EI, it's 25.5%. Quite often, our estimates fall close to each other, but they rarely fall exactly the same, because of course these are estimation procedures, but it doesn't really matter if it's not exactly the same. You don't really need to know if it's 94.4 or 94.9%. What you know is that an overwhelming percentage of Black voters supported Warnock, and only about 25% of white voters supported Warnock. This contest then is racially polarized, with Black voters supporting one candidate and white voters supporting that candidate's opponent. So if the election was held among Black voters alone, Warnock would have been elected, and among white voters alone, Loeffler would have been elected. If this pattern continues over a series of elections, voting is racially polarized in that particular jurisdiction. If the Black preferred candidate usually loses, the racial block voting rises to the level of legal significance, and if you can draw a district, you need to draw a district or you're violating the Voting Rights Act. Okay, next slide. What I want to do now is talk about a couple of issues involved in doing a racial block voting analysis. But actually, let me take a second to talk about how defendant jurisdictions have tended to deal with evidence of racial block voting before I talk about this for a second. Traditionally, the attacks have been either on the basis of definition. What do we mean by what is a white bloc that's voting against? What do we mean by cohesion? What does usually mean? What does it mean that you usually have to be defeated? So there's that approach to attacking the process I just described to you. And another is a set of statistical issues. So, for example, we're not talking about individual voters here. We're estimating how voters are voting on the basis of aggregate data. So we have to deal with challenges about the possibility of aggregation bias. We have to talk about how reliable these estimates are, especially estimates that go, say, over 100% or less than 0%. What I didn't talk about is that these estimates come with standard errors and confidence intervals. And depending on the statistical package that you use, they're easy to report or less than easy to report. But the idea is that the larger the confidence interval, think of it as sort of margins of error when you're looking at poll results. The larger the confidence interval, that means you have a larger area in which the actual result, the actual estimate is actually falls. So you want confidence intervals that are smaller, so that you're more you have more confidence in your estimates. So what you typically do is report the standard errors and the confidence intervals for your estimates, usually in an appendix, because it's not they're not readily explainable, but it's a good idea to know how large your confidence intervals are. It's also possible that you can't produce reliable estimates at all. For example, if the minority group is very small, you will not be able to produce estimates. Or if you have a very small number of election precincts, you won't be able to produce reliable estimates. There's another factor that's not just that you have to have, say, a dozen or more precincts, and that you have to have, say, a sufficient number, maybe at least 10, 15% of your voters have to be the minority group that you're interested in, but there has to be spread across the precincts. There has to be variation in the percentage minority in each of the precincts. If those conditions aren't met, you're going to get estimates with very large confidence intervals, if you can produce estimates at all. Okay, that was a little aside, but that's an idea of some of the things that you would have to grapple with if you're going to court with these estimates based on these kinds of statistical techniques. You're going to have to be able to say that you have reliable estimates and you've got standard errors and confidence intervals to show that. And you're going to have to tell the court what you mean by white bloc voting and minorities being politically cohesive, and what usually losing means. Okay, so now what I want to do is I want to talk about if you could go back, I want to talk about a line of cases that we've seen in the Fifth Circuit. Beginning with LULAC v. claims. This is specific to the Fifth Circuit, and this is a complication only in the Fifth Circuit as of now, but the idea behind the amendments to Section 2 in Section 2 of the Voting Rights Act in 1982 was amended to make it clear that the intent to discriminate does not have to be shown. It's merely a matter of the results. Do the voting patterns result in minorities usually losing, and would drawing a minority district mean that they could win some elections? LULAC basically was a way of getting intent in through the back door, because what LULAC said was, actually, I don't care if voters are voting differently if, for example, it's party and not race that explains it. So the court held that voting is racially polarized only where Democrats are losing because they are Black, and not where Blacks are losing because they are Democrats. Now, again, this is getting intent through the door. through the back door, because now we have to try and figure out how to separate race and party. And the problem is, statistically, you can't really do that. If you tried to do that, if you did a cross-section of voting patterns, you would, chances are, miss the causal inference behind this. Essentially, we know, especially in the South, and we've known for a long time, Lyndon Johnson, when he signed the Voting Rights Act, had a pretty good idea what was going to happen in the South, and that is that white voters were going to leave the Democratic Party and Black voters were going to embrace it. And we can see fluctuations in white and minority support for the two main parties based on things like the racial and the civil rights policies they espouse. So the idea of separating these statistically is, it just isn't going to work in the kind of analysis that we're doing here. But voting rights cases have been lost because we can't show that the voting patterns can be explained by race alone. For example, if, based on a case I was involved in Texas, if Republicans who are Latino are elected, even if they're not elected with Latino support, but only white support, the idea was that, according to the court, the voting, these candidates were supported despite their race, and therefore it's party and not race that explains the voting patterns. So it makes it very difficult in the Fifth Circuit to bring a successful voting rights case. Okay. The next complexity I want to talk about is how to balance the Voting Rights Act, Section 2 of the Voting Rights Act, against 14th Amendment's racial gerrymandering cases. So starting in 1993 with Shaw v. Reno, the Supreme Court decided that race cannot be the predominant factor in drawing districts unless the Voting Rights Act requires the creation of these districts. So you have to do a racial bloc voting analysis to determine if Section 2 would be violated if you didn't take race into account when drawing these districts, such that you were creating a remedy for a potential Section 2, or when Section 5 was still operational, Section 5 problem. Then in 2015, the Alabama case sort of added another wrinkle to the situation, and that is that it's a racial gerrymander if legislators, redistrictors, simply pick a demographic target, say 50%, and apply it across the jurisdiction, say across the state, and draw all minority districts on the basis of this demographic target. What the court required was a district-specific functional analysis. And in fact, in the Shaw v. Reno line of cases, if you're going to argue that the Voting Rights Act requires you to draw districts, then you have to draw narrowly tailored districts. And in both instances, the result is the need to do a district-specific functional analysis to determine if you have produced narrowly tailored districts that satisfy the Voting Rights Act. So you can't use arbitrary targets. In fact, you can't even use race at all unless you know that the Voting Rights Act will be violated. And if it is going to be violated, you need to draw districts that will correct for that, but not go beyond correcting for the Voting Rights Act. So what do I mean by a district-specific functional analysis, and why am I talking about it here? And the reason I'm talking about it here is that the district-specific functional analysis that I do is based on the racial bloc voting analysis that I just described to you. So, for example, before drawing districts, I can do a racial bloc voting analysis, and I have an idea of the relative turnout rates of, say, whites and minorities. I know the amount of cohesion among minority voters, and I know basically how much white crossover vote I can expect. By white crossover vote, I mean, we know that the majority of voting is polarized. The majority of whites are consistently voting against minority preferred candidates, but some amount of white voters are supporting that candidate. In fact, when we look at congressional districts now, we see that the majority of, say, African-American congressional representatives are elected from districts that are not majority minority in composition. There is enough white votes for these candidates to win in districts that are less than 50%. Say, for example, Black in composition. So we can use the voting patterns that we've discerned from our racial bloc voting analysis to predict how much cohesion there is, how much crossover there is, how much we have to correct for differentials in turnout to produce an estimate of the percent, say, for example, Black voting age population needed to provide Blacks with an opportunity to elect their candidates of choice. Then we can also use the racial bloc voting analysis once proposed districts have been drawn, and we can do that by choosing elections that we know are racially polarized, and using those elections and recompiled election results to determine if the minority preferred candidates would have won those polarized elections in the proposed election, in the proposed districts that we're talking about. I mentioned very briefly in the last training session how we can disaggregate precinct level election results down to the block group on the basis of, say, the number of voters that we know that are in that block, or if we don't have that information, the voting age population within that block, and then recompile those elections up to reflect any proposed districts. And based on the racial bloc voting analysis, you would have an idea of some bellwether elections, that is, elections that fit the description that I just gave you. The elections were polarized, and it had sort of an average amount of white crossover that we expect in that district, and it's sort of average amount of cohesion to see if that candidate would have carried that election. So those are two kinds of district-specific functional approaches that we can use based on racial bloc voting analysis to see if we have districts that will provide minorities with an opportunity to elect without being cut too close or without unnecessarily packing minority voters. I think that's my last slide. Oh, yeah, well, there's the description of the district-specific functional analysis that I was just talking about. The first approach used prior to drawing proposed districts, and the second approach can be used once proposed district boundaries have been drawn. And I think that's it. Yes. So I think we're going to open it up to questions now.
Amazing. Before we get to the Q&A, probably one question all you folks have is actually wanting what to look for in a practitioner. So we have a slide here actually, and I'll go over sort of the bullets here. I want to sort of shout out Kate Donovan, who helped in this process of creating this list, as well as a few RPV experts that took a look at this. So just know that folks looked at this and confirmed the validity of what's being said here. So I'll just go ahead and read it off the bullet points. So what to look for in a practitioner: assessing Gingles 1 as well as Gingles 2 and 3 require different skills. So for Gingles 1 requires mapping skills, so either a demographer, geographer, or GIS analyst. Gingles 2 requires statistical skills, so either a statistician or a political scientist. As well, they would need prior experience serving as an RPV analyst or providing expert testimony is, of course, ideal. Also, any work in voting rights analysis, any times they testified in court or submitted expert testimony, and any times they were criticized by the courts for doing something wrong. Otherwise, for Gingles 2 and 3, you can ask whether they are comfortable with regression, so used in ecological regression, have conducted ecological inference analysis, have previously worked with data sets being used in analysis, so election results, census data, etc., as well as understand and can interpret point estimates and confidence intervals. As well, definitely a must. You can also ask whether they are comfortable with programming software, such as R, which has some packages available to facilitate RPV analysis, or Python, and as well their previous or current colleagues and collaborators that they have worked with. So great, let me go ahead and stop sharing my screen. And let me go ahead. So just as I was saying at the beginning of the presentation, we do have a couple minutes for questions, but definitely try to keep the questions as related to the presentation as possible. If the question is unrelated, we will just kind of let you know that's how we cannot answer it. So definitely don't take it personally. We just sadly aren't able to answer the question. But you could either do one of two things. You could put a stack in the chat and I will call your name. And you can ask your question, or you could just simply type your question in the chat and I'll read it off for you. So I'll wait for any questions that come in and see if there's anything that's coming through. Great, let's see. So the first question I see is from Blake. Can Dr. Henley talk about tools / packages that can be used?
That's an excellent question, and I should have mentioned this. It's getting easier and easier. So long as you can work in R, the software package R, which is free, there are packages in there that will run all of these analyses for you. So I use two packages. One's called EI Compare and the other is called EI Pack. And with those packages, you can produce your homogeneous estimates, your ecological regression estimates, and your ecological inference estimates. They'll provide standard errors and confidence intervals if appropriate, and it's all in a single package. So it's getting easier and easier to do this analysis. So, and again, the software is R, it's free, anyone can download it, and there are, I guess they're called sub packages that are designed specifically to do this kind of analysis.
Amazing, Blake says thanks. Angelo asks, thanks, Lisa. A few academics have been pushing Bayesian improved surname geocoding, or BISG, as a technique to improve EI. So, for example, is formally presented as an option to the California Redistricting Commission last year. Without getting into the technical details, what's your opinion of this technique? Is it too novel for the courts? If a group or agency is underwriting an RPV analysis, is it worth any extra time and expense to have an expert use BISG?
Last week, I talked about how you want to actually get as close to the electorate as possible when you're doing this kind of analysis. So at the precinct level, if you're using voting age population and you have differences in turnout between the two groups, then it's you're further away than you would want to be. If you had a voter file that indicated to you who actually turned out, you would be closer, especially, for example, if you were in the South, where some of these jurisdictions are actually telling you the race of the voters. What's and I did talk about this technique a little bit last time, and that is that for decades now, the census has collected surnames. If more than I think more than 100 people have the same surname, they will report the surname and the race of the proportion of people. So, you know, say you've got the name Handley, and it says so. 78% of people who identified their surname as Handley were white, and 22% were Black. So each of these surnames come associated with the proportion of the racial groups that identified that as their surname. And that's been used to figure out the actual composition of the electorate. And with some groups, it's very good. So if you were in a jurisdiction that had, it's particularly good with Hispanics, and the probability of getting it correct is quite high with Hispanics. It's not as high if the groups that you're interested in are Black voters and white voters. So it always depends on the jurisdiction as to how reliable these kinds of estimates are. And you're using proportions anyway. It's not like the old Spanish surname where you had to say yes or no. You're assigning proportions to these voters and adding them up. I think that in a place like California, where you have a lot of Hispanics and a lot of Asians, it's better than, for example, in jurisdictions in the South where you're only dealing with Blacks and whites, where it does not as well, not as good a job as in other areas with other groups. I'm not sure that it's incredibly expensive to run it, because the group that you talked about in California has actually not only produced an R software package that helps you run these ecological regression and inference estimates, but they've also produced a package that produces probabilities assigned to surnames using the BISG methodology. On the other hand, you've got to go in and geocode the voters, so that is complicated. Okay.
Alrighty, we have 5 more minutes, so we'll have 3 more quick questions to go through. Rebecca asked, what was the brown-yellow coloring for the lines in the tomograph? And I'm happy to share my screen if that's helpful. I believe it's this here.
Okay, so the only thing that I see that's brown are the lines, and those are the precincts. I don't see any yellow. So well, each of the lines represents a precinct, and all of the probable results given the composition of the precincts.
Yeah, I was just wondering what it looks like the kind of horizontal ones, and yeah, those are orange, and then up a little, there's some yellow diagonal ones. And then I was just wondering what that color map is corresponding to.
It is, that's a good question. I think it just has to do with how many precincts. So the lighter number means that we've got less precincts down there, and the darker number means that we've got more precincts. But you know, I don't really know that for a fact. I produced these an EI compare, and I think it just has to do with the density of the precincts.
Okay, thank you.
Alrighty. Jackson asks, can one determine an expert's conflict of interest?
Conflict of interest. Well, what you could do is, I'm not sure that you would call it a conflict of interest, but you would want to see, presumably your experts probably published in this area, and you want to know what they've said in their publications, and you want to know what they've said in previous cases to make sure that they're not contradicting themselves. say, for example, than the case that you're putting forward. But in terms of conflict of interest, I'm not exactly sure what I mean. I guess if you could elaborate, unless I've actually captured what you meant.
Thank you, Lisa. You have. I was also wondering, since I have done litigation a decade ago, are there any sample retainer agreements that can be shared for retaining experts? Because I assume that once you retain an expert, the hope is that they don't have any other clients or cases that may pose philosophical or other conflicts in the way they approach the Gingles evaluation, for 2 and 3. So I agree. Yes, it's true that sometimes the articles that they have published have come back to haunt you and bite you because the other side has found some contradiction in the way they have published some opinion years ago, and then it's brought back into the deposition or into the current litigation. So that is a very important thing, to know what your client or know what your expert has said or will say.
I don't think that I have ever run across a contract that has said something like, whatever you say here, you can't contradict in another case, because you would never do that anyway, or you're going to, as an expert, be called not credible. But certainly contracts include provisions for confidentiality, and for you can't work for, say, not only, let's say there's a big litigation, you can't work for two sides or even two jurisdictions a lot of times that are likely to have conflicting ideas about, say, what a redistricting plan should look like. So in that sense, there is a conflict of interest. You can't work against your clients in a different case.
Thank you.
Oh, you're muted.
Oh, sorry about that. Final question. Blake asks, could Dr. Handley comment on how to determine the geographic extent of the area being analyzed?
So that's kind of complicated, except that when you have a database in front of you, you will have to choose off of the information you have in the database. So if I had a statewide database, I could choose my unit of analysis, say, on the basis of a county or a township or a state legislative district, because that piece of information would be in my database. So sometimes I have clients that say, well, can you look at this area? It's like, well, not really, because you have to have some way of selecting the precincts that you're interested in. So typically the areas are those areas that are included in the census database that you have, or in the elections database that you have. So again, you're talking about administrative areas or election districts.
Alrighty, I believe that is all the questions, and we just hit the 2 p.m. mark. Blake says, great, thank you. And great, the last question, and great question from Sarah as well. Will the PowerPoint along with the video recording be emailed? Yes, it will. So once we get the recording up, I will send an email out to you folks of both the PowerPoint and the recording. So definitely look out for that. And as well, if you had a question that wasn't answered today, please send us an email at info@redistrictingdatahub.org. Typically take around 24 hours to get back to you. So definitely send us an email if you have any questions from today. But just want to say again,